Hello, physics students. Today I'm going to be talking about the turning effect of forces. This concept that not only can forces change something's direction, but they can also change its orientation in space. So our objective today, by the time I am done with this lecture, you will know how to correctly calculate a moment of force, or what I will refer to as torque. So a moment of force and torque, these are two different ways of saying functionally the same thing. I will also be referring to a pivot and the turning effect of a force, which is, the kind of the core idea of this whole unit. So getting started, normally what we've talked about so far is forces and their ability to cause what is known as translational motion. That means the box is oriented as such, and if I put a force to it, I can move it and it doesn't change the direction or the orientation of the box. But I can also use a force to move something around a pivot point, and this is what we refer to as rotational motion. So I can rotate, say I've got this line right here, I can rotate it up like this, and I can change the orientation of the line by applying a force right here. Now this only works if I'm dealing with a pivot, and it causes the object to move in what's known as a circular pattern. So, a moment of force is a quantity that tells us about the force that is causing the turning effect. And what has to happen is that it has to happen around what's called a pivot. This is the central point, either like a pin or a shaft, something like that, around which something turns. And the turning effect is literally the effect of a force turning a lever or a wheel. So in this example, we have a wrench. If I apply a force right here, it's going to cause this whole wrench to twist like this around the pivot because the pivot is anchored and cannot move, but whatever is on that pivot can rotate. So here are some really common examples of objects that take advantage of torque, and the first one is the most common example. This is a seesaw. By changing the distance between the gentleman 1 over here and gentleman 2 right here, I can change the amount of force they're applying to each other on the seesaw. Although in this case, I'm not sure I'm going to be able to change the force enough to actually get poor gentleman 2 right here out of the air and back onto the ground. Another example would be like trying to twist in a screw. So you apply your force to the outside edge of the screw, and it is anchored into the piece of wood by what we would call our pivot point. Wheelbarrows operate in the same way. The pivot point is the wheel of the wheelbarrow, and you can lift using the handles right here, causing a force to go that way and tip the wheelbarrow. Hammers, another obvious example. The pivot point is actually right here. Oops. I hope I like that the way it is. Pivot point is right here, and we can use these prongs on the hammer, if I create a force here, to rotate the hammer this way and take the nail with it. Scales, another really easy example. And then finally, one we're all familiar with, doors. Doors operate on hinges, and those hinges right here allow us to apply a force and open the door. So, things you guys need to know is that the moment of force is bigger if the force is bigger. This one is not too terribly shocking, but if you try to slam a door versus open it quietly, you're changing the amount of force. But the second one is slightly less obvious, so this is going to be the one that I want you guys to make sure you're paying attention to, is that a force, or the moment of force, torque, is bigger if it acts further away from a pivot. So, for instance, if I have that wrench example, I'm going to draw a terrible wrench here, and this is a terrible wrench. So, if I apply a force here, it's going to have a different and smaller effect on motion than if I apply my force way back here. So this is going to get me a larger torque value, and this is going to get me a smaller torque value. So the moment of force is bigger if it acts further away from the pivot. So if this is my pivot, I could measure this being distance 1, or I could measure this being distance 2, and the farther away I am, distance 2, the larger my force is going to wind up being. Now, in order to calculate that, we do have an equation. And so this is your equation for moment of force. Moment of force is equal to force times the distance to the pivot. Now this has to be a perpendicular distance to the pivot. So once again, if I have my ugly wrench, and I'm going to draw the ugly wrench one more time. This one is even worse than my previous one. Now, this is a straight line from the pivot to where I'm applying the force from right here. If for some reason this wrench had a handle that did something like that, I would still measure from this, from this to the handle. It doesn't matter how many twists and turns it makes. It has to be the perpendicular distance to the pivot. So your equation winds up being moment of force, or torque, is equal to force times distance. The unit for this, because force has its own unit, and that's in newtons, and distance has a unit, and that's in meters. We don't have a new unit for this. We just wind up calling it a Newton meter, or an NM. So that's going to wind up being the Newton meter, and that's what you guys need to know for the math side of things. So in summary, we have this thing called the moment of force, or we can also call it torque, and I'm going to abbreviate torque with this T that has kind of the squiggly top on it. And this is basically, we're using this to describe rotational force, or force that's happening around a pivot point. So this is all well and good. Remember that torque is equal to force times the distance away from the pivot. So once again, that's the distance away from the pivot, and it's measured perpendicular, so it doesn't matter what your handle winds up looking like. You're just going to wind up measuring from the pivot to the point that the force is being applied. And that's all you guys need to know about that. I will see you guys in class.